Okay, we've got a pair of unknowns, two unknowns, so we're going to need two equations to solve those uniquely. If we only had one, there would be an infinite number, but that's another video. So what I've noticed here is the difference. So it's much easier if I rearrange this a little bit, and I generally tend to put, to save getting too many negatives, I put the smaller one underneath there. Just click back on transform. And you'll notice this one has got 2x's compared to 1x, and that's got 1y the same as 1y, and the difference is 2. So even with very young children not using algebra but using cups, you can see that the extra x must be worth 2. But we're looking for a method here. So I've noticed these two are the same. So what I'm going to do is I'm going to find the difference. I'm going to subtract. So this one minus this one, this one minus this one, this one minus this one. So if I do, I'm going to have a new expression. So the difference between those is x, or 2x minus x is x. The difference there, or y minus y, is 0. So we just have equals. And then on the other side, 7 minus 5 is 2. So that's what we noticed. Because of the extra x, it must be 2. So I was going to copy that one down over there, because that's what we ended up with underneath. And I can rearrange that a little bit, because I like to have it tidy. We've got this. So what I'm going to do now is I'm going to substitute this x value into the simplest equation. So I'm going to copy this equation over here. Didn't quite move where I wanted it. There we go. And I now know that x is 2. So in here, in place of x, I'm going to replace it with 2 by dragging the x and putting it on top of there. Now in order to find y, I'm going to do something to both sides. So I click on the equals there, and I'm going to subtract 2 from both sides of the equation, because I've spotted a 0 pair there, and that leaves me with y equals 3. So I have x equals 2, so let's copy that over there, and I also have that y equals 3. Let's copy that over there. Now let's have a look at our two equations. So we'll copy that one down there, and we'll copy that one over there. So what I'm going to do now is to show that this works. So we think that that solves this and this. So I'm going to take x is 2 and substitute it in there. And I'm going to take y is 3 and now substitute that in as well. And we see that 2 2's plus 3 does in fact make 7. So that worked for the first equation. Now I'm going to substitute it in here and put x is 2 in there. That gives me that. Then I'm going to substitute in the y there as well. And you can see that 2 and 3 does make 5. So we found the unique pair of values, the only pair of values that should work in both equations. And we did it by spotting that these didn't match, but these did match. A lot of simultaneous equations is about finding matching things. So there I subtracted them to find the difference, because that would eliminate the y. So this method is called elimination.